This is a GCSE Maths video on trial and improvement and solving equations doing that. This is quite a straightforward wee topic. You just need to be careful and show you're working out with anything that you're doing. So it says work out the whole numbers first, find two consecutive numbers between which the solution lies, then work numbers to one decimal place, and if necessary work to two decimal places, and test the number halfway between the two consecutive decimal numbers to get close to the exact answer. That'll make no sense whatsoever, but hopefully you'll see once you start going through it. So it says solve the equation x cubed plus 3x minus 25 equals 0 by trial and improvement, and you're asked then to give your answer to one decimal place. So pretty much it's a guessing game. So let's pick a number that we think might work. So let's go for, we're going to try the number 2. 2 cubed gives me 8. Plus 3 times 2 plus 6, take away 25, gives us minus 11. Minus 11 is smaller than 0, so that number is too small. So we're going to try something bigger. We're now going to try 3. 3 cubed is 27, plus 3 times 3 is 9, take away 25. That gives us 11. That number is bigger than 0, so that number is too big. We're asked to give our answer to one decimal place, so we'll now start going to decimal numbers. We know it's in between 2 and 3, so we're going to try then 2.5. 2.5 ends up giving us, let's see, I think if you add those together, 23.75. You can take my word for it, I've just put it into the calculator there. We get minus 1.875. And that number is getting pretty close. That's not too bad at all, but that number is too small. So we're going to try something a bit bigger. So we're going to try 2.6. If you put in 2.6 again into this formula here, you will get 0.375. And that number is just too big, but we're pretty much there, I think. So we know it's in between 2.5 and 2.6. It looks very much like it's going to be 2.6. The reason I'm saying that is that's closer to 0 than that is. So we need to check halfway in between these two numbers. I know we're asked to go to one decimal place, but for this question you need to go to 2 just to check. So halfway in between this and this gives me 2.55. If you sub in 2.55, you will get, let me just check this on the calculator. I think we get something like minus 0.769. So that definitely means our answer is on the kind of higher side then of that, if that makes sense. So our answer then correct to one decimal place is going to be 2.6. Hope that makes sense. Effectively, this is a guessing game. You try different numbers, try sensible numbers, and if your number is way too big, you pick something that's a wee bit smaller and work your way out. Here's the important bit of this. For the exam, you need to show you're working out. So each of these lines need to be in. The problem is people get going in their calculator and they forget to put in their attempts and stuff like that, and that's then where you'll lose your marks. You need to show you're working out as you're working your way through it. Let's take a wee look at example 2. Solve the equation 2x cubed equals x plus 1.8. I'm going to rearrange that. Actually, you can do it a couple of different ways. You can take everything over to one side, a bit like the one above, and work it out to be 0, but I'm going to try and solve the equation 2x cubed minus x and get that as close then to 1.8 as I possibly can. I hope we can kind of see that that's going to work out for us. So let's pick a number. Let's pick the number 1. So if I put the number 1 into this, 1 cubed gives me 1 times 2, take away 1. That gives me 1, and that number is too small. I'm now going to try the number 2. We're asked to get the two decimal places here. So 2 cubed gives me 8, times 2 is 16, take away 2, that gives me 14. That is too big, and it's way too big. So I now want to pick a number in between this. Often you kind of pick 1.5, but I'm going to pick something a wee bit closer to 1 because it looks like it's going to be way closer to this than it is to this. So I'm going to try 1.2. If you try 1.2, so 1.2 cubed times by 2 Let's show exactly the calculation I'm doing here. So it's 1.2 cubed, and then I times that by 2, and then I take away 1.2, and if you do that in your calculator, you will get 2.256. We want 1.8, so that number is too big. So I'm going to try 1.1. And if I do 1.1, it's 2 upon 1.1 cubed, take away 1.1. That gives me 1.56. So I'm getting somewhere here. It's in between 1.1 and 1.2. Remember, this one's at 2 decimal places, so we need to go a wee bit further. It looks again like a wee bit closer to this one than this one, so do something a wee bit closer. So I'm going to try 1.13. If I try 1.13, it's 2 upon 1.13 cubed. Take away 1.13. Sorry, this one here, I should have written this too small. Take away 1.13. If you put that in a calculator, you get 1.755. So we're getting pretty close here. We want that one still too small. So I'm going to try the next one up. 1.14. 2 times 1.14 cubed. Take away 1.14. Put that in the calculator. I get 1.823. Effectively, that's too big, but it looks like it's going to be our answer to 2 decimal places. I hope you can kind of see that. So I guess to me, 1.8 is closer to this number than it is to this number, so I suspect it's going to be that. But for these, you always have to go to the extra decimal place, so halfway in between is 1.135. So 2 upon 1.135 cubed. Take away 1.135. That gives me 1.789. So it's on the higher side of 1.135, so it's then going to be 1.14. So my answer then to 2 decimal places is 1.14. As I say, just a bit of a guessing game, only it's sensible guesses. I tried 1, I got 1, quite close, tried 2, way too big. So kind of pick sensible ones and show you're working out as you're working your way through. That's trial and proof.